Light is the messenger of the universe. Through the study of light, mankind continues to unravel the mysteries of the cosmos. But in order to comprehend the faintest light from the farthest reaches of space, we need darkness. As humanity's presence on planet Earth grows, it becomes harder and harder to find a truly dark sky. Atmospheric and light pollution clouds our view of space. Yet, there are still some special places that offer stargazers a unique window into the universe. I'm Gary Fildes, head astronomer at the Kielder Observatory in the English county of Northumberland. For me, gazing up at the nighttime sky is not only my career, but my passion. However, I haven't always been a professional astronomer. I grew up in the 1970s in a working class area of a town called Sunderland. And at that time, it wasn't famous for its cosmologists or astrophysicists. Like most of my mates, I left school at 16 and went to work on building sites, where I stayed for over 20 years. It wasn't until I was in my late 30s that I got involved with the construction of the Kielder Observatory and began to follow my dream. Now I work here in the heart of beautiful Northumberland.
The real reason why we're here is because we don't have any light pollution. Light pollution is something that we get in the inner cities especially, and it hinders our view of the nighttime sky. But here, where we are now, it's one of the last bastions of dark sky we've got in the UK, and it really is phenomenally dark.
But in order for it to stay dark, it must be protected by law. The International Dark Sky Association is an organisation committed to the protection of dark skies around the world. They have certified over 65 dark sky parks across 6 continents, legally preventing light pollution and preserving the asset of darkness. I've made it my mission for Kielder to be included in this amazing initiative, so that generations to come can gaze unhindered into the universe. To truly understand what dark sky preservation is all about, I'm embarking on a quest to meet the people who do it best under the darkest skies on planet Earth. I'm off to Chile in South America.
This is it, we're in Newcastle Airport now, really excited. This is the start of the day, all the bags are checked in, really excited. Next thing we're going to know, we're going to be in Chile in the Atacama Desert. Absolutely phenomenally excited.
Embarking on a journey like this is really a dream for me. Since I was a boy, I've read about Chile's rich history of astronomy and looked in awe at pictures of the largest telescopes in the world. To see them firsthand, well, it might just blow my mind. My odyssey begins with a 15-hour flight to Santiago to Chile. Plenty of time to contemplate the cosmos. I remember when I was 7 years old, my brother got a telescope for Christmas. He didn't seem so interested, so I set it up, pointing it out of my bedroom window. It took me a while, but I managed to find the moon. I think that was the moment that I became hooked on space and began to dream of the stars. I had no idea that my dream would take me so far. get my first taste of life in South America with a walk through the busy streets of Santiago de Chile. There's the smell of unfamiliar food cooking, music in the air, not to mention some very interesting characters. Quite a change from Sunderland. Santiago is not only a buzzing modern metropolis, it is also the birthplace of modern astronomy in Chile. The Manuel Foster Observatory sits on Mount San Cristobal in the centre of the city. It was built way back in 1903 and was one of Chile's first observatories. Today, it sits up here as a relic of the past, but it played such an important role for this country and for science. Hernan, a seasoned Chilean astronomer, has agreed to show me the ropes.
Hi Gary.
Hello.
Nice to see you.
Yeah. Hernan, how long have you actually been an astronomer then?
Oh, it's just 40 years since my first paper. I've been now 31 years in Chile. And the other 10 years I was in the US, it was the National Radio Astronomy Observatory. In Europe was the European Sun Observatory, which is all Europe. And in Canada also was the NRC Observatory. Just to get the experience, okay, to eventually help to develop astronomy in Chile.
I can't help feeling a real sense of classical awe and wonder when I'm in here, of how it all started off back in the really, really early days. Who actually had the idea for this instrument, who built it, and who actually designed and built the observatory?
Well, this it came from the Lick Observatory. It's a twin of the Crossley telescope there. This one was the biggest in the southern hemisphere for 15 years at the beginning of the century. The way of operating here, everything was manual. This telescope had no electricity in the original days, okay? You operate here in the open. And after a long 13 hours night and winter, it's painful, I tell you.
This telescope is definitely old school, but it also reminds me a bit of Kielder, with its hand-turned gears and pulleys. Sadly, it became redundant some time ago, and as darkness falls on Mount San Cristobal, it is easy to understand why. The lights of the vast city now cloud the night sky. It's a perfect example of how light pollution impacts our view of the cosmos. Exactly what I want to avoid for Kielder. As the sun rises over Santiago, I have an early morning meeting to get to. Chile is so serious about its night sky, it has a government minister dedicated to dark skies preservation, and he has agreed to spare me some of his time.
Nice to meet you, thanks for seeing me. So, one of the things I really want to ask, Viceman, is why is the preservation of dark skies so important?
Tiene que ver básicamente con la iluminación, pero no cualquier iluminación, especialmente la iluminación pública, también la iluminación industrial y también la iluminación comercial, o sea, aquellos avisos publicitarios. Y respecto a esa iluminación, las cuestiones más relevantes que uno tiene que controlar a través de la norma, en primer lugar corresponde a la iluminación hacia el cielo.
Understanding how important dark skies are to this nation is inspiring. I'm hoping that I can take some of that back with me to Kielder. Now, as much as I'm enjoying Santiago, it's time to take the next step of my journey.
So for me, leaving all this behind and getting out into the desert is why I'm here. It's to get into these true dark skies that Chile has and explore these phenomenal scientific facilities, where humanity is gathered together to explore our universe.
To find them, I will have to head north into the desert. But first, there is a place in the outskirts of the city that I just have to see. The Cerro Calan Observatory is home to the University of Chile's astronomy department. It's amazing to think that a new generation of astrophysicists are honing their skills right here. I'm meeting Professor Mauro Hume to understand a bit more about how important astronomy is to Chile.
Hello.
Hi Gary, nice to meet you, and welcome to Santiago.
It's brilliant to be here. Look at this.
Yeah, we have a fantastic view here.
When I come here, I'm thinking astronomy in Chile started in the 60s, but that's not the case, right?
No, actually it started in 1848 in the middle of downtown Santiago when there's still not much light pollution. Now, that's the beginning of the National Observatory, and then in the late 50s it moved to this place, the Cerro Calán Observatory, looking for a darker side, running away from the city lights.
Yeah.
And unfortunately, as you can see now, we are surrounded by buildings, highways, shopping centers, and we are again surrounded by city lights.
Yeah.
So this is not a very good place to do astronomical observations today, but over many years, since the early 60s, it did a very important contribution to astronomy.
So Mauro, I'm just so excited. I can't wait to get out there at these observatories.
When you head north, you will see an amazing geography, amazing observatories, and an incredible dark sky.
I think I'm beginning to understand how important astronomy is to this country. Now, it's time for me to find out why. As dusk sets in, I head away from the light-polluted city to see how the night sky looks in a less populated area.
We're driving north, we've been 3-4 hours out of Santiago now. I'm getting a real sense of how incredibly dark the sky is going to be because there just isn't any outdoor lighting anywhere. I'm going to pull over and I'm going to set my gear up and see if I can get see if I can get my first taste of this incredible Chilean sky. But the excitement levels are high because I can see how dark this place is going to be. There just isn't any outdoor light anywhere. It's going to be incredible. There's no clouds in the sky, as you can see, and I know that within a couple of hours, easy, then we're just going to have this cornucopia of stars above our heads.
Heading way off the beaten track, I find a spot that looks perfect for an astronomical campsite. To make things even more exciting, I'm here at a time in the year when the moon does not appear in the night sky, so it will definitely be dark. And I've brought some kit to do some observations of my own. I remember as a child, growing up in Sunderland, we weren't conditioned for academia and universities, and never even knew what a university was. We were destined to work in factories, in the shipyards or on building sites. But in all the years I was laying bricks, I was always thinking of the stars. The universe is an awe-inspiring environment for anyone who wants to think about reality and their own existence. Ever since mankind walked on the earth, we've looked to the night sky for answers to our deepest questions. And of course, the deeper we look out into the universe, the further we look back in time. I think that's what really captivates me. Seeing the past unfold before our eyes on a cosmological scale. As darkness falls on my improvised observatory, the truth of why Chile and astronomy are so entwined begins to become clear.
Well, this is my first glimpse of the Chilean dark sky, and I can't wipe the smile off my face, to be quite honest. I had an idea what it was going to be like. I knew it was going to be dark, but I didn't expect this. And there it is.
It's just beating down on me, this engine room of our galaxy. I'm looking back 15, 20,000 light years distant. It's a then I'm seeing now because it's took so long for light from that incredible thing to get here. And that's just the type of magic that hooks me into astronomy.
Directly overhead is the galactic centre, the heart of our Milky Way galaxy. A spiral of over 300 billion stars beaming back at me. It's no wonder that some of the world's biggest telescopes are here. Tomorrow I travel north into the Atacama Desert to visit a legendary observatory. But first, I must remember to get some sleep. As I hit the road and continue north, I really start to understand the importance of the geography here. Although a lack of light pollution is integral, the landscape also plays a vital role in Chile's dark skies. I am sandwiched between the Pacific Ocean on my left and the Andes mountain range on my right, in a desert with high altitudes and almost no rainfall. These conditions are ideal for astronomy, and that's why 70% of the world's largest observatories are here in the desert. And it's not long before I spot my first destination.
Wow, look at this. This is phenomenal. That is the edge of the Atacama Desert, and there is La Silla. Look at the scenery, it's phenomenal. It's just flat and vast and just seems to go on forever.
The La Silla Observatory sits on a plateau 2,400 metres above sea level and has been operating since the 1960s. It's part of ESO, or the European Southern Observatory, and is home to a duo of very special telescopes. The NTT, or the New Technology Telescope, became operational in 1989 and was the first telescope in the world to have a computer-controlled main mirror. With it, scientists are studying star formation and the galactic centre. I'm having a look around the ESO 3.6 metre telescope that houses HARPS, or the High Accuracy Radial Velocity Planet Searcher. It is dedicated to the discovery of extrasolar planets. To be invited into this facility is a huge honour for me, and I'm a little overwhelmed to think that the next great discovery in space could be happening around me now. I'm even allowed to talk to the astronomers as they work.
So it's a zoom in.
Which one is it?
It's Omega Centauri.
Okay, oh really?
Yeah.
Cool.
And we hope to discover some pulsating star in it. We know that there exist a few here and here,
okay.
And we hope to discover other.
Okay. After my tour of the control room, darkness sets in, and Hernan, my guide here, takes me outside to share some historical Chilean astronomy.
The Milky Way was so clear for them, so bright for them. They were very used to see the dark part.
So they ignored the light and concentrated more on the dark.
Right. Well, here where you can see this dark part of the galaxy, that's the Llama. You can see the head of the Llama, and then you can see in the Alpha Centauri the eye of the Llama, and then you have the neck, and then the body and the legs.
Yeah.
That's the whole Llama constellation. It's a very big constellation, actually.
That's fantastic.
Well, you know, for these people, llama was the basic of the economy, so they saw llamas everywhere.
It's fascinating to think that ancient civilizations focused on the darkness rather than light. After a decent bit kip, it's time to get on the road again. But before I leave, Hernan wants me to see something special on the mountainside beneath the observatory.
So we call this La Silla El Molle Archaeological Site. It's a very important archaeological site. We have here more than 1,000 stones of this culture, El Molle culture. They came from the Amazonas 2,000 years ago. Actually, these are dated by 300 years before Christ.
The ancient petroglyphs on these stones depict constellations and planets that seem familiar.
So is this cross Venus then?
That's Venus, yes.
So this is over 2,000-year-old astronomy.
Yes, yes. That's what we think.
Absolutely magical.
So, and you can see 21st century astronomy.
Yes.
You know, so they were here long time before we were.
Yes, absolutely.
Looking to the sky.
I don't know. It's a really surreal feeling. It's an emotional feeling as well. It really, really is, because in my work in astronomy, the type of things I try to do quite a lot is interpretation. So bridging the gap between that and this, essentially. So in the absence of a framework we call science, the Lemoyes as a culture looked at the nighttime sky and lived their lives, almost, it seems, it appears, by what they saw in the nighttime sky. When I see things like this, we see one aspect of the interpretation of astronomy in our universe, and then we see modern 21st century astronomy interpreting what the universe tells us. But this is just science-free. This is just heartfelt emotion about what they saw and what it meant to them. And it's one of the most incredibly emotional things I think I've ever saw.
I find it utterly fascinating to think that throughout history, as with today, mankind has looked to the sky for answers. The El Molle were doing it here all that time ago, just as I'm doing it now. I'm really starting to feel like I'm experiencing the astronomical wonders of Chile. But I know that I've only scratched the surface. And in my eagerness to get to the next observatory on my list, I've made a slight miscalculation.
So I'm heading north now to Paranal, which is pretty much one of the biggest days of my life to be going here finally. This incredible institution of science and astronomy. And one of the big problems I've got now, which is more foremost on my mind at the minute, is that last night, because of the horrendous fog, foolishly I went past the filling station, and now my needle is on red, and I'm in the middle of the Atacama Desert, 60 kilometers from the town of Tal Tal, where a filling station is. So I may not even get there.
I'm pretty sure that I'm running on fumes at this point, but I'm desperately trying to stay optimistic.
If this goes, I've got quite a walk. It's quite poetic, really, here in Chile for the science, and it's gravity might save the day, because the town that we're heading for, Tal Tal, is at sea level and we weren't. So I've got 20 kilometers to do downhill, and the engine's not on. I'm just rolling essentially. So hoping, I think I'm maybe another 17, 18 kilometers to go. And there's condors certainly. Interesting.
Just as the engine splutters, I see a sign for the town.
Well, I made it. Quite literally just rolled down the hill. Gravity saved the day. And I've literally just rolled onto the forecourt, empty. I don't think it would have lasted anything more than minutes to get here. And so, I'm just so relieved.
A moment's rest, a full tank of fuel, and a lesson learned, and I'm on my way again. Next stop, the Paranal Observatory. The Atacama is a truly dramatic landscape and a far cry from the northeast of England. It covers over 40,000 square miles of northern Chile and is the driest desert on the planet. It also has an average altitude of over 2,000 meters above sea level, and it's incredibly beautiful. It almost feels like the surface of a planet somewhere in a galaxy far, far away.
So just climbing and climbing and climbing now, and you can see the sky's beautiful. It's a crystal blue, big, vast blue sky, and like the excitement levels reaching fever pitch as we crawl up this road, this hill, to the premier outpost that mankind has for exploring our universe, VLT. Can't believe I'm nearly here.
The Paranal Observatory sits at an altitude of 2,635 metres and is renowned as the flagship facility of European ground-based astronomy. It's home to the VLT, or the Very Large Telescope, the world's most advanced array of optical telescopes, and to VISTA, the Visible and Infrared Survey Telescope for astronomy. It was also used as a location in the James Bond movie Quantum of Solace. The prospect of seeing this facility up close and personal is pretty overwhelming, so much so that my eagerness may have got the better of me.
So, I don't know, because I can't speak Spanish and he couldn't speak English, but essentially the gist of it was, we're in early. It looks like maybe an extra night in. So we'll see, maybe they'll say, because it's been my fault. I have actually arrived a day early, and that was not intentional. It's just when you're out here, you just lose track of time, and I just did, and I thought it was today, but it wasn't. It's supposed to be tomorrow, but they've let us in anyway, so if I can stay for the duration, what it means is I've got an extra night.
Fortunately, my hosts are very welcoming and don't tell me to get lost. Paranal is a true wonder. The entrance here leads down into what's known as the Residencia, which is essentially a hotel of sorts for the astronomers who are working here. Outside is the driest desert on the planet, but inside has a tropical climate. As I relax for a moment, I pick up a paper and spot someone familiar in Chile's national press.
One of the things that struck me when I read the article was that he's me, little old me, in El Mercurial, being sort of highlighted as this ambassador for dark skies and light pollution at the place where the world's largest observatories are gathered. It's phenomenal, right? I can't believe it. It's incredible.
As comfortable as it is in here, it's not where the science happens. On the plateau above the Residencia is the VLT itself, and even though I'm a day early, my gracious hosts have granted me access to the world's largest array of optical telescopes. British astronomer Dr. Roger Wesson works here year-round.
Hi, Roger.
Hello, Gary. How are you doing?
Hi, I'm well. How are you?
Good, thanks. Nice to see you here. Welcome to the platform here at Paranal. We've got about an hour to go before the sun sets here at Paranal. We're starting to activate all the telescopes and instruments, and we'll go and see the opening of UT3.
Okay, excellent.
The VLT consists of 4 unit telescopes, each with a main mirror of 8.2 metres in diameter. The 4 mirrors can work together to form one giant interferometer, creating a resolution of around 50 milliarc seconds. In other words, it can distinguish details smaller than a DVD on the International Space Station. That's some serious resolution. And to think I'm actually inside UT3 as it's gearing up for a night of observations.
I've never seen anything like this. This is the most amazing thing I think I've ever seen.
What a feat of engineering. And to think there's nothing else like it on Earth. It's pretty humbling.
Could I imagine 10 years ago being here? Not in a million years ago. No, absolutely not. I mean, I knew this place existed and I was in love with astronomy, definitely. But, you know, where I've came in the last 10 years is I often think about that and I try to quantify and work out what's happening. I can't really. There wasn't any master plan. It just happened. I just talked to people about astronomy,
and enjoy it, and this is what's brought me. And so 10 years ago I was working on a building site, and now I'm here at the VLT, so no, never could I have imagined I'd end up here in 10 years. What a journey.
As darkness falls, it's almost time for the science to begin. Just beneath the telescope are the control rooms where all the data is recorded and analysed. French astronomer Dr. Julien Giraud seems happy to share his work with me.
Hey, how you doing? You all right?
This is a very red region. In the visible you wouldn't see anything. So in the infrared you see thousands of stars there. And then there is a place where we know the black hole is. We don't see it directly.
Absolutely.
But what people do is look at the motion of the star across,
Many
years, months. Even from one month to another, you can already see things moving.
This astonishing technology is providing humanity with new insights every night. It's spine-tingling to think that mankind's next big discovery could be happening here and now. As a new day dawns on the desert, I wake to realise I'm actually at Paranal, and it's not just a dream. To be here, under the darkest skies on the planet, to witness cutting-edge astronomy is something that will stay with me for the rest of my life. But before I leave, and because I accidentally arrived a day early, my incredibly generous hosts have arranged for me to see VISTA, the Visible and Infrared Survey Telescope for Astronomy. It's the world's largest survey telescope, and it's dedicated to mapping the sky. With it, we are discovering new quasars and studying the evolution of galaxies. I'm meeting head engineer Gerhard Hudepol to learn about this astonishing piece of kit.
Like that, and how does this thing work?
Well, let's say what is very special about this telescope, it's a survey telescope, so it has a very large field of view for a telescope.
Yeah.
So you can actually look at the full moon and it fills your field of view. And it has a very fast optics, f1, so it's extremely light sensitive.
Yes.
And actually it was quite complicated to polish the mirror. It has a very steep curvature, so this was a real challenge to polish a 4-meter mirror to f1 speed.
So all the light that mirror gathers has got to get up into that tube, right? All of it,
Yes.
every single photon.
Yes, exactly. And to get actually the perfect image, this is an active telescope. So the M1 mirror, the main mirror, is an active mirror. It has actuators underneath, which adjust at any time during observation the mirror to the perfect shape. And then, as you said, you concentrate the light on the secondary mirror, and then it falls back into the camera.
It's absolutely breathtaking. I want one.
You want one?
Yes. I'm going to get one of these and take it back to the UK.
Well, you've got to keep dreaming. My time here at Paranal has been a dream come true. As I am preparing to leave, I glance once more up at the telescopes.
It's hard to believe now that I was in there last night. When I work at the Kielder Observatory, I work with small aperture instruments. We talk about interpreting the universe, how we see it. But that is quite literally science and mankind's portal into the universe. Science, astronomy, physics is continually looking for more answers into where we are in the universe. But it's not just about the optical light, because there's more to light than what we can just see. So now I'm off north into the Atacama Desert.
My ultimate destination for this trip is ALMA, or the Atacama Large Millimeter Array. It's a radio telescope that is considered the largest experiment ever attempted by mankind. I've got quite a lot of desert to cover, so it's time to hit the road again. On this odyssey, I've spent so much time looking up at the stars in these incredibly dark skies. It's been easy to ignore the landscape around me.
There's nothing around here at all apart from rock, hill, sand, road, me, and the incredible, vast blue sky overhead, which just dwarfs everything else.
Being alone in the expanse of the Atacama Desert can at times be quite emotional. I just need to stop for a minute to take it all in. As dusk once again falls on the road, I think it's time to pitch up for a night of camping in the desert. Just me, a glass of Chilean red, and the Milky Way. Heading north once again, I set my sights on the town of San Pedro de Atacama. It's the closest place to the ALMA facility, and I've been told it's a must-see. Arriving here, I can see that it's a hit with the tourists. In fact, this is probably the most people I've seen in one place since Santiago.
This town's full of vibrancy, really. It's colour, there's sound, there's like dogs just lying everywhere and kids running around playing with them. There's a real feel for Chile in this town.
It doesn't take long for me to understand the charm of this place. The red earth buildings, blazing sunshine and relaxed vibes are a welcome break from being on the road. Just what I need before I visit ALMA, which sits at an inhospitable altitude of over 5,000 meters above sea level. I have been warned that it's no cakewalk and there's a high risk of altitude sickness, but I've come this far, so I'm not backing down now. Perhaps a glass of red and a steak could ease my anxiety. Heading up to ALMA, I first arrive at the entrance of the foot of the mountain, and before I can ascend to the base camp known as the OSF, I have to undergo a safety course, all very serious. Driving up, I can't help but notice that for the driest place on Earth, there seems to be a lot of clouds. I arrive at the OSF base camp just in time to witness the final sub-millimeter dishes being readied for transport up to the Chagnantor Plateau. It's phenomenal to be here, just as it is coming together. Talk about cutting edge. ALMA is effectively an array of 66 of these mammoth dishes that can all work in unison to record data from the farthest reaches of the known universe. Astrophysicist Dr. Andreas Lundgren is lucky enough to be working up at this exciting facility.
Well, ALMA is a quantum leap for radio astronomy in special. The extragalactic sources, they emit radiation in all wavelengths. And so with an optical telescope, you just see a dark patch of this on the sky.
Yeah.
But with a radio telescope, it lights up like a big fiery place. And ALMA, not one single telescope, it's constructed based out of antennas that we couple together using a supercomputer called a correlator. And together, these antennas will work as one single unit telescope.
I'm obviously very keen to get up to the plateau to see the array firsthand. But first, they want to give me a checkup.
This is over 16,000 feet, and if it's a bit nerve-wracking. I'm not allowed to do any of the observatories because they're not that high. But the thing is, with this one, it's over 16,000 feet, right? So if I don't pass my medical, I ain't going up. Is it good or bad?
It's good.
It's good?
Yes.
After some umming and ahhing, they finally give me the thumbs up. However, the weather seems to have gotten worse.
I was up at 5 a.m. this morning to get up to the OSF, which is where I am now, at ALMA, which is essentially base camp. So there's a problem, and that problem is the weather. They're not quite sure whether they're going to allow me up there. Fingers crossed that the weather stays the way it is, and hopefully I'm going to get right to the top, which is 5,000 meters. So it's right up there, and I'm excited, but a little bit nervous at the same time.
Finally, we receive the green light and begin our ascent. The road ahead is a long, slow climb, and the clouds are growing heavier.
We've just had to stop at a checkpoint on the way up, so we're on our way essentially. We've got another 2,000 meters to climb.
And the weather doesn't seem to be letting up.
You expect when you come here to have, I mean, essentially this is why they built the array where it is because, you know, traditionally and historically the weather here is extremely dry and arid. When I was actually down at the bottom, it looked as if it was getting brighter, but it wasn't. I was wrong. It's actually getting worse. It's actually started to rain.
I can't help but feel that I have brought the Kielder weather all this way, and to make matters worse, the mountain is against me too.
Wow. Well, I'm at 4,000 meters now, and I mean the first thing I want to say is that what an incredible view. It's absolutely phenomenal. But I am starting to feel the effects of the altitude. It's nothing major, but you definitely feel like you want to gasp a little bit more for air. We've got another just over 1,000 meters to go to the top, so it's another over a kilometer before we get to the top. So yeah, I might be gasping for breath by the time we get there, but I'm all right, ready to go.
The ALMA array is something that I've been so excited to see, but it seems as though my luck may have run out.
So we've just hit 5,000 meters now, and this just was not what I expected. It's a whiteout, a complete whiteout. I was expecting to see big blue skies and little white antennas scattered around the plateau, but it's just a complete whiteout.
On reaching the top, I realised that my mission to ALMA, mankind's greatest experiment, is not turning out quite how I'd hoped.
It's phenomenal to be up here, seeing this Atacama large millimetre array at the forefront of science, but you know what, the weather, as you can see, is closed right in. It's absolutely horrendous. I just did not expect to bring the weather from the northeast of England all the way to the Atacama Desert. So, whilst it's incredible and fantastic to be here, and the weather's sort of dampening spirits, there's little doubt about that, but the real big problem is oxygen. The team are really feeling it, and I am as well. Didn't think I would, and the way in which I'm feeling is really weird. I fell asleep pretty much in the car coming up, and I feel like, I know it's really weird. Just give me a second. It's a real battle, it really is. You might not think it because it's just a snowy surrounding, but wow, can you feel the effects of this? It's absolutely incredible.
As we hastily head back down the mountain, I can't help but feel a sense of disappointment. Having come all of this way, only to be beaten back by the most freakish weather that they've had here in decades. I do still have one more astronomer to meet tomorrow. He's in charge of Apex, or the Atacama Pathfinder experiment, which is effectively the forerunner for ALMA. Hopefully, it will make up for today's huge disappointment. It's morning just outside San Pedro de Atacama, and typically it's a beautiful crystal clear day. I'm arriving at Apex to meet Dr. Michael Dumpke to take a look at the facility.
Hi, Gary.
Nice to meet you.
Welcome to Apex.
Yeah, thanks.
Yeah,
Brilliant to be here.
Yeah, how was your trip?
It was good.
ALMA is they can look in very fine detail at small sources.
Yes.
While we can get the big picture. We
Yes.
can take big maps of large areas on the sky, like scans over the whole galaxy, for example. And we can find sources, and ALMA can look at these sources in finer detail.
Rather excitingly, Michael has offered to take me up the mountain to see the instrument itself. And the drive up is a far cry from the harsh conditions of my previous ascent.
Oh. Hey, there we are. So I suppose the view is any better than the other day when we were up here, right?
Well, it's completely different. I mean, when I was at ALMA, it was just grey, barren landscape, low visibility, and a blizzard. This is beautiful. It really is. It's lifeless, isn't it? Nothing could survive here, apart from scientists and science. The very earliest movie of film, The Thing, when they're all trapped in the Arctic wasteland. It's got a feel of that about it. Maybe not.
Should we have a look at the...
Yeah. Yes, absolutely.
Clearly, Michael is not a huge Kurt Russell fan. Come to think of it, neither am I. Unlike the many dishes of ALMA, Apex is a singular antenna, but it's still a really phenomenal piece of kit. It's a 12-metre diameter telescope that operates at millimetre and sub-millimetre wavelengths. That's between infrared light and radio waves. Sub-millimetre astronomy opens a window into the far reaches of space, allowing astronomers to study the earliest and most distant galaxies in the universe. If my hands-on tour of Apex hadn't already made up for the disappointment of ALMA, Michael has another surprise for me.
Yeah, I mean, you have this great weather today, and since you didn't see ALMA, maybe we can pass by on the way down and have a look at ALMA again.
We can do that?
Yeah, I think so.
Really?
Yeah.
Oh, that'd be brilliant.
Yeah,
That would be absolutely incredible.
Yeah, let's try it. Yeah.
Super. Jeez, thanks for that.
It may not look like it, but I can hardly contain myself. As we travel unhindered up to ALMA, I can't help think how amazing millimetre and sub-millimetre astronomy is. These instruments can operate in daylight, making them 24-hour telescopes that allow us to see further than ever before. Arriving at ALMA on such a stunning day, it's easy to see why it's the biggest experiment on the planet. Oh, wow. Gee, look at that.
Yeah, it's quite impressive.
So these will be observing now?
Yeah. They are in operation and they're observing.
So some of these dishes now could be looking at early time galaxies, maybe 12, 13 billion light years back in the universe.
Yeah.
So light from these sources, from these emitters, falling onto these in the sub-millimetre wavelengths now as we speak. Wow.
This incredible project is the forefront of modern astronomy, capable of discovering organic molecules, the fundamental building blocks of life itself. As it probes the far reaches of the universe, It's bringing us ever closer to our own cosmic origins. The grand scale of the science here in Chile can to most feel inaccessible. But what unites us all is that innate sense that we are part of something bigger, that each and every one of us are and always will be part of this awe-inspiring universe. As the sun begins to set in the Atacama, it is time for me to reflect on my epic journey. From Sunderland's building sites to the Kielder Observatory, and of course here, under the darkest skies on planet Earth. I've realised so many dreams along the way, La Silla, Paranal and the mighty ALMA. It's an incredibly humbling feeling to behold these amazing pieces of mankind's ingenuity. In this science lie the answers to humanity's burning questions about the universe. Yet, none of it would be possible without dark skies. And that's why the people of Chile protect this asset ferociously. Understanding this has only galvanised my own ambitions to preserve the dark skies back in Kielder, to protect the UK's clearest window into the universe for generations of stargazers to come.